Welcome to our online lesson for A-level chemistry. Today's lecture is about solutions and concentration. In details, we will talk about the calculations related to solutions. After this lecture, hopefully, you will learn how to do the calculation about solutions correctly. Let us begin. The concentration of a solution is the amount of solute dissolved in a solvent to make 1 cubic decimeter of solution. The solvent is usually water. There are 1,000 cubic centimeter in a cubic decimeter. When 1 mole of a compound is dissolved to make 1 cubic decimeter of solution, the concentration is 1 mole per cubic decimeter. We use the terms concentrated and dilute to refer to the relative amount of solute in the solution. A solution with a low concentration of solute is a dilute solution. If there is a high concentration of solute, the solution is concentrated. When performing calculations involving concentrations in mole per cubic centimeter, you need to, Step 1, to change mass in grams to moles, Step 2, to change cubic centimeter to cubic decimeter by dividing the number of cubic centimeter by 1,000. Now, let us calculate the concentration in mole per cubic decimeter of sodium hydroxide, if 250 cubic centimeter of a solution contains 2.0 grams of sodium hydroxide. The relative formula mass of sodium hydroxide is given as 40.0. Step 1. Change grams into moles, so we get 0.05 moles of sodium hydroxide. Step 2. Change cubic centimeter to cubic decimeter. And at last, we calculate the concentration by put 0.050 over 0.25. Therefore, we get the answer, 0.20 mole per cubic decimeter. We often need to calculate the mass of a substance present in a solution of known concentration and volume. To do this, we need to firstly get the moles by multiple the concentration and volume. Then multiple molar mass with the result. So, let us calculate the mass of anhydrous copper sulfate in 55 cubic centimeters of a 0.20 moles per cubic decimeter solution of copper sulfate. First, change cubic centimeter to cubic decimeter. Then, we get the moles. At last, we get the mass. Note here, we need to keep the answer to two significant figures. A titration is often used to find the exact concentration of a solution. The next example shows the steps used to calculate the concentration of a solution of sodium hydroxide when it is neutralized by aqueous sulfuric acid of known concentration and volume. So for this example, the first step is to calculate the moles of acid. We use the reagent for which the concentration and volume are both known and get 0.00302 moles of hydrogen sulfide. In step 2, we use the stoichiometry of the balanced equation to calculate the moles of sodium hydroxide. We multiply by 2 because the balanced equation shows that 2 moles of sodium hydroxide react with every 1 mole of hydrogen sulfide. In step 3, we divide by 0.0250 because we have changed cubic centimeter to cubic decimeter. The answer is given to 3 significant figures because the smallest number of significant figures in the data is 3. We can use titration results to find the stoichiometry of a reaction. In order to do this, we need to know the concentrations and the volumes of both the reactants. This example below shows how to determine the stoichiometry of the reaction between a metal hydroxide and an acid. Step 1. Calculate the number of moles of each reagent. Moles of metal hydroxide. Deduce the simplest mole ratio of metal hydroxide to hydrochloric acid, and then write the equation. Therefore, the calculation suggests that 1 mole of hydroxide ions neutralizes 1 mole of hydrogen ions. As 1 mole of the metal hydroxide neutralizes 2 moles of hydrochloric acid, the metal hydroxide must contain 2 hydroxide ions in each formula unit. As a summary, we have talked about calculation on solutions and concentration. Do not forget to subscribe to our channel. That is all for today. Have a nice day and bye.